No, let's calculus again. This is what we stopped with yesterday, where we were switching x and y, then solving, getting it back to y equals again to find the inverse. So what we're going to look at today is this stuff right here. Let me clear out what's in here. And I think this is basically all we did the whole time. So let me get that out of the way. Okay, so what we're going to do here is we're basically going to fill out this table. And the nice thing about this table is that it's really pretty easy. It kind of looks a little more scary than it really is. So I'm going to go ahead and start filling it out. I'm going to do 2 of them. Then I'm going to let you do the last one. Or I might let you do the middle one. I'll decide as I go. And if anybody texts you and says that they want to come into this, make sure that you tell me, because I can't, I have to invite them in now. It's kind of a pain in the butt. Okay. So what we're going to do, we're looking at this. And the first thing you have to do is understand that we're starting, our first one here is just f of x equals 2 to the x. And that just looks like one of these guys. It's flat on this side and it goes up forever. So to find out what happens, this tells me I go down 3. This, I set this equal to 0 and I solve it. If I add x to both sides, I get x equals 3. So this tells me I go right 3. And that negative right there tells me I reflect across the y-axis. So I Beyonce it. So you have to make sure that you understand that kind of stuff first. So questions on that stuff first. Okay, if not, I'm going to go on to the new stuff. The new stuff is this kind of stuff. Our domain, the nice thing for this one, if you look at this, it goes forever that way. It goes forever up and kind of to the right. So our domain for this is negative infinity to infinity. Now, what this negative does to it, this negative makes it go this way instead. We reflected it across the y-axis, so it looks like that now. So now my range, you have to remember, we went down 3, so we're starting at 3 and we're going up forever. And then my horizontal asymptote is just y equals the number that's at the end. So questions on that part, are you okay with that? Hearing nothing?
Dewey's coming, by the way.
Oh, I thought he was already in there. Oh, let me admit him. I thought I did already. Admit. Yes. Go ahead.
Wouldn't the range go from -3, not +3?
It totally would. I was wanting to see if any of y'all are paying attention to me. Thank you. You okay with that? Now, the nice thing about it, once you know those, this piece right here, because everything right here had to do with f of x. Now, over here, we're going to the inverse. But what's kind of cool about this is that my domain and my range, they just flip-flop. They switch places. And my vertical asymptote, I'm going to take my horizontal asymptote for right here and just change the value on it. So this one would go this way. This guy right here is going up and down at -3. I got somebody else wanting to come in. Let me take a look at this real quick. Conrad's coming. Okay. So now I've got Dewey's in here. Conrad just showed up. Okay. So now, these 2 things, ask me questions on those 2 because you're going to have to be able to do that. Okay. If there's no questions, this piece right here is what we did yesterday. So we're going to take our original over here and we're going to switch the x and the y. X equals 2 to the negative y plus 3 minus 3. We're going to have to solve this for y. So the first thing I do is I add 3 to both sides. Because this is a 2 right here, I take both sides to log base 2. And this is just basically a cheat way to get us around that exponent. Because if the base Let me get that parentheses. And the argument match, we just end up with log base 2 of x plus 3 equals negative y plus 3. So remember, we're trying to find our inverse. So to find our inverse, we have to solve for y. So to solve for y, I'm going to take y to the other side to make it positive, and I'm going to subtract the log term from both sides. And then basically, I get rid of the y, and I just make it the inverse equation. So this is the equation of the inverse. So take a look at that. That's the part that people had the hardest time with this morning. Anyone? Okay, that's the hardest part. We found the inverse of the equation. Now, it tells you exactly what to do right here. Set the argument of the inverse equal to 0. This is the argument. And if you'll notice, this guy is the same as that guy. And then it says set the argument greater than 0 and solve. X has to be greater than negative 3 if I write this in interval notation. This guy is the same as that guy, which is the same as that guy. So basically what you have the inverse, you can find out what the domain of the inverse is if you do this. And you can find out what the vertical asymptote is if you do that. And if we're talking about the inverse, the range forever and ever, amen, is always negative infinity to infinity. So I'm going to pause for 15 seconds, and I'm going to see if anybody has any questions for me. Okay, that was 15 seconds. If there's no questions, I'm going to give you another example. I'm going to take a look at this guy right here. Okay, and then I'm going to leave you this one to do here in a second. So we're going to do this guy right here. So the first thing we have to do is we have to do the domain and range. So to do the domain and range, my domain, if it's one of these, is just negative infinity to infinity. Now let's talk about the range. This tells me if I said x minus 2 equal to 0, x equals 2, that tells me I'm going right 2. This tells me I'm going up 1. That negative tells me I'm reflecting across the x-axis. So that's kind of important because our parent function, y equals 3 to the x, it does one of these guys. If we're going to take this negative out front, it's going to take it and flip that over and make it look like that. So a horizontal asymptote's above it. And that's important because that tells us what our range is going to be. Our range for this one is negative infinity up to that number. And that number is 1 because our horizontal asymptote is just the number at the end. So you've got to be careful. If you have a negative like up here, that doesn't change. It just goes side to side. Sorry, guys. It doesn't change the up and down. If you have a negative up front, it changes it from going like flat on the left up to the right, from flat on the left down to the right. So it changes like where you start and stop at. If you're good with that, this part's easy. Just switch. Oops. Just switch. Your domain is now going to be negative infinity to 1. Your range is going to be negative infinity to infinity. And this time, your vertical asymptote is going to be at x equals 1. And your vertical and your horizontal asymptotes always either have to have an x equals or a y equals. If you just put the number, you'll get it wrong. So now, if I am looking at this piece right here, I want to find the inverse function. The first thing I'm going to do is I'm going to say x equals negative 3, y minus 2, plus 1. That's my first step from yesterday. I switch x and y. My second step is to solve for y. Subtract 1 from both sides. Now here's a step you're going to make sure you pay attention to right here. This step, I don't want this piece over here, the exponential term, to be negative. So if I multiply everything by -1, all the seconds change. And now this tells me what my base should be. Log base 3 of -x plus 1 equals log base 3 of 3 to the y minus 2. So this stays the same. I'm going to come down here and write it so I can write a little bit bigger. I've got log base 3 of -x plus 1 equals, because those two are the same, that's our cheat. It cancels out. I'm going to add 2 to both sides. And if you want to make that 1 minus x, that's fine. Make sure you shut the parentheses. Plus 2 equals y. But remember, our last step in part 2 is to change the y to the inverse. So this is the inverse of that. Now, again, they just want us to take the argument, set equal to 0, x equals 1. So this is our vertical asymptote. They match. Then they want us to take the same argument, say it's greater than 0. Now be careful with this. I subtract 1 from both sides, but y'all know if you divide both sides by a negative number, you have to flip that sign. So I end up from negative infinity to 1. This is it in inequality form. This is it in interval notation. So ask me questions on that. Anybody still with me? Okay, if there's no questions on that, I'm going to pause myself for 2 minutes. I want you guys to try this one. Okay, so I'm going to mute myself for 2 minutes. If you have a question, ask. I'll unmute myself. But you guys, I'm going to move it up a little bit so you see what you have to find for everything. You guys figure these out for this equation. I'm back. Anybody need any more time? Someone, please say something back to me.
I'm good.
Okay, thank you. Thank you. I'm going to step through it kind of quickly so y'all can see it. Again, I know this is telling me up 3. This, if I said x plus 2 equal to 0, I get x equals -2. This tells me I'm going left 2, there's no reflections at all. So I know it's going to be doing something like, it's going to look something like that. So now my domain, doesn't matter what it looks like. For this type, it's negative infinity to infinity. My range, I'm going up. So I'm going 2 to infinity. And then my horizontal asymptote is y equals 2. I hope that makes sense to you guys. If it doesn't, please ask. Okay, so now flip-flop my domain. For the inverse again, we're talking inverse, is 2 to infinity. My range is negative infinity to infinity. Yes.
Wouldn't the range be from 3 to infinity since 3 is the horizontal?
Oh, shoot fire. You're right. Okay, I didn't do that on purpose. I try to act like I'm cool like I did, but I didn't. That should be a 3. That should be a 3. That should be a 3. And that should be a 3. See how I fixed it? Y'all are so lucky to have me. I got to keep telling you guys that so you believe it, okay? Okay, I'm running out of room right here. So I'm going to come down here. I'm going to make it green. And I'm going to come up with the inverse right here. So I'm going to say x equals 3 plus e to the y plus 2. Subtract 3 from both sides. How do I get rid of e?
Don't you have to use
LN.
Yep, perfect. ln. ln of x minus 3 equals ln of e to the y plus 2. So this just stays the same. But the ln and the e undo each other, so I get to drop that down. So I end up with my inverse, which is my y equals being ln of x minus 3 minus 2. Y'all okay with that? Your lack of a response tells me you're okay. So that's what goes right here. So now set the argument. Our argument is x minus 3. X equals 3. And this guy matches that guy, which it's supposed to do. And then I take the argument and I say it's greater than 0. X has to be greater than 3. So then I'm going to go from 3 to infinity. This and this is in inequality form, interval form. This matches my domain, which matches my range. So let me show you this real quick, what this means, because it's easy just to put all this on here, but let me show you what these look like. So if I come over here and I go to y equals, I'm going to clear out what's in there. I'm going to do the one we just did. So I'm going to say 3 plus e to the x plus 2. And I'm just going to hit zoom 6, and we're going to look at it. There it is right there. Just to make it look a little bit better, I'm going to go to my window, and I'm going to say, instead of going negative 10, I'm just going to say negative 1. I'm going to hit graph. We don't really need all this over here, but I'm going to leave it for right now, because what I'm going to do now is I'm going to go to y equals down here. I'm going to sub this in, and I'm going to say the ln of x minus 3, making sure I shut the parentheses, minus 2. I'm going to graph it. Now, notice how it's way down here. We can't see it as much. I'm going to go to my window. I'm going to make this a negative 20. I'm going to make that a 20. I'm going to come up here and just do everything to 20. I'm a little anal. I like everything to match. I'm going to hit graph. And what you'll notice, see how it disappears? It shouldn't really disappear. This is what's wrong with these calculators. This guy should keep going down. It doesn't. But if you'll notice, if I could come in here and I'm going to attempt to do this, and it's not going to be, well, I'm not going to do it this way. Well, shoot fire. Maybe I can, maybe I can't. If I draw a line, it's not going to let me. Let me try using this over here. If I draw a line, y equals x, let me move it down. What you will notice is this will reflect across this down here. And it just goes away because your calculator can't handle it. So this is the original. This is the inverse. And it would actually kind of keep going. It's not going to let me do it. Going down that way. But I don't know, for whatever reason your calculator flips out when it does that. But this is just what it looks like. I think sometimes it's nice to see what it looks like. So that's basically all we did today. Okay, so 7.5 is open. You're welcome to work on it. I'm going to finish it up tomorrow. But that was it from this morning. Any of you all have any questions about this or anything from 7.4? Because remember, 7.4 is due tonight. And just so you know where to put it, if you come over here, if you'll notice this is first period, 13 of 17 people have already turned it in. So just take a picture of it with your phone, or if you can't, take a picture of it with your Chromebook and post it right here. So any 7.4 questions for me?
Nope.
Anybody? I got one no. Anybody else? Okay, if there's no questions, I'm gonna jump off then. Anybody has anything for me?
Wasn't there going to be a test on like 7.3, 7.4?
Yeah, let's look at that real quick. If I come over here, I go to my NTI stuff. Everybody knows what this is, right? If you don't, make sure you ask me because it's like awesome. We're going to have, I'm just going to look at first period right here. We're going to have a 7.3, 7.4 quiz tomorrow on my open math. I can't remember. I think it's only like 3 questions. It's not a whole lot. I'm going to finish up 7.5, answer any questions on 7.3 or 7.4 that you might have. And then that quiz will be open for 24 hours tomorrow. Any other questions for me? If not, I at least want you all to come on here and tell me goodbye.
Bye.
Bye. Anybody else?
Bye.
Bye.
Yeah.
Bye.
Bye.
Bye. Bye, bye, bye. Okay, I'm gonna get off here. See you guys later.